ಕೊಡಗು ಧ್ವನಿ ಡಿಜಿಟಲ್ ಮೀಡಿಯಾ. ಇದು ಕೊಡಗಿನ ನಂಬರ್ 1 ಯೂಟ್ಯೂಬ್ ಚಾನಲ್.
Up any research on extraterrestrials, or are they real or just a myth?
Like for beyond our earth, we will be doing multiple experiments.
My question is, what is the great attractor which all the galaxies are headed into? Is it just a myth, or what all information we have about that?
We'll start with Earth and Moon. Okay, the Moon is rotating around the.
There is also opportunity for you to come through GATE score. If you have given a GATE exam, through GATE score also you can come, but the chances is very less. 25% of people only come through GATE score, otherwise 75% people are through ICRB only.
Like you are preparing many missions or rockets, so you will be having some of the health issues, or you will be having the stress towards it, like to succeed. So how will you overcome that stress and health problems?
Family members also, they know what kind of work we are doing, and they will give full support for us.
Yes, contribute to ISRO.
Saw some videos during when I was conducting the quiz. There were our landers and there were arms coming out and taking the sample. There were rovers which were moving. All that is robotics. If you want to extend an arm like what we do in our hand, you need robotics. So robotics is like the baseline of any planetary exploration. And coming to AI, like future projects, like if we want to deploy some multiple small rovers, they have to communicate with each other. You imagine on Moon there are some 100 rovers going everywhere. There will be one master rover which will command it where what to do. That builds AI is the base for that. So AI and space robotics is like very much required for our future exploration. Anyone wants?
Cryogenic technology is very much required for lifting heavyweight satellites into GTO orbit. Okay, beyond orbit. So any fuel, we have actually a specific impulse is there, and efficiency of the fuel. Okay, so efficiency of the fuel of cryogenic fuel is more. So to use cryo fuel, we require cryo engine, and it gives higher thrust when compared to any other fuel. Whether it is a solid fuel or a liquid fuel, cryo fuel will give a higher specific impulse and thrust when compared to other.
Which fuel actually provides more thrust to the rockets, sir? There is LOX, some liquid oxygen kind of fuel you're using, right, in the engines?
So actually solid fuel will give the higher thrust,
yes.
But actually what I'm telling is the efficiency. For example, for this quantum of fuel, what is the thrust it imparts? It is more for cryo. But initially, when you lift a big mass, when the rocket, when we lift off, basically we use solid fuel for that. It gives higher thrust.
Actually, solid is like our Diwali crackers. Once if you ignite, it will start, correct? But whereas cryogenic, it has got a special feature. You can control and you can change the thrust, whatever is required. If there is some angle orientation is there, that can be done through cryogenic. For that only we have kept in the last stage where we can change the trajectory, and it can put that satellite into the required orbit. That is the advantage, one more advantage of cryogenic.
Yes. Thank you so much.
Up any research on extraterrestrials, or are they real or just a myth?
Like for beyond our earth, we will be doing multiple experiments. So in that we'll try to find out what is the environment there, what is the chemistry there and all. So in fact that will give us some traces if in case there are some microorganisms or something like that. So it will tell us that yes, there is a room for, there is actually some living beings there, or there is room for living beings to do like that. So all our experiments will try to find out the environment there, the soil composition. Basically that will in turn give that. So we don't have any extra special mission to find out aliens or like that.
Thank you.
My question is, what is the great attractor which all the galaxies are headed into? Is it just a myth, or what all information we have about that?
Not clear.
great
We'll start with the Earth and Moon. Okay? The Moon is rotating around the Earth, right? So there is a gravitational pull and other things. And these both together they are rotating around Sun. So now our Milky Way galaxy is also, because Sun is also rotating with something else. What is that? That is a black hole, right? So like this, many galaxies are there. There may be some more things, and we have to study about that. That's why we are putting some more spacecrafts in the orbit. Why we cannot do it from here? See, this the black hole or some other thing, if you have to see, you have to go into different spectrum of frequency, like X-rays, gamma rays and other things. From Earth, we will not be able to see. So that's why we are putting a spacecraft in the orbit. And then we are putting some telescopes. You might have heard about Hubble telescope and
JWST.
Yeah. So such kind of things. And experiment will go on continuing. See, today we have learned this much. We have to learn some more. So it is like that. It will be keep on going.
Thank you.
While launching rockets or any satellites. Thank you.
Stepping stone is failure. We have faced a lot of such things in our domain because it's a very critical technology, and failures are bound to happen. First thing is, you should never lose heart, should not lose trust in what you have believed so far. So you have done lot of experiments, you have done lot of research, lot of testing goes into making a satellite. So don't lose trust and don't lose heart. And I can say more specifically, Indians are very good in finding out ways to tackle failure. If one plan A did not work, we usually at ISRO will have at least 3-level redundancy. If plan A is not there, plan B. If not plan B, plan C. So, but space, environment or conditions throw challenges to all our plans. Like all the 3 plans may not work in the situation what we have. So we should be able to tweak all 3 plans and come up with plan D, which can actually work in the challenge what we have faced. So we can convert that failure into success. So that is what we kind of follow. We usually try to use all our experience from the seniors and all our missions what we learned, and every failure is dealt very seriously. We have rigorous reviews after that. We try to find out the real root cause, why it happened, and we ensure that failure doesn't creep into the next mission. So those experiences and the technology and the skills what we have, we try to use and try to make sure that failure is converted into success.
Okay, so and we learn from the setback. If you see the Chandrayaan 2, the poster here, it says the objective of the mission was almost 99% complete. So actually it didn't do a soft land, but there were multiple objectives. So any failure, no, it will be we should use as a stepping stone. We have learned from our seniors that every problem or setback we face, no, we will bounce back actually. So as Priyanka rightly said, we have multiple plans, plan A, plan B, plan C and all. So space is prone to failures or prone to setbacks. We will be always saying, see, there will be a lack plus components in a satellite, and if a particular component fails, so we will have a setback. So the probability of failures are more in space industry. Okay, even very experienced space operators face the problem. Even like American space agencies or European space agency, we face this actually. This is inherent into the space industry, but we take every failure as we term it as setback. We don't call it as a failure, and there will be lessons from that. So usually failure as a setback is a thing, but we should ensure that second failure should not happen of the same type. It is a criminal thing. So usually we take care that such failures are addressed, and whatever setbacks or learnings from each project, it will be passed on to the subsequent projects. So they will be addressed very seriously and carefully. And when you see Chandrayaan 3, it was a roaring success. So we just took all the inputs from Chandrayaan 2 mission and we came back successfully in Chandrayaan 3. So that's how ISRO does.
Huge round of applause for that answer and that wonderful question. So there
2 points here. One thing is we have to learn from our mistake. Not only that, we have to learn from some other person mistake also. For example, I want to learn riding a cycle. Let us think. I have to, if I press a front brake, I will fall down. So that is already, it is known, it is experienced by somebody else. Same mistake we should not do. Not only we have to learn from our mistake, we have to learn from others' mistake also. So you no need to do the same mistake every time.
next question.
Good challenging conditions, how to maintain your health and your body levels. Those are the kind of trainings that will be similar to whatever any other astronaut would go through in any other space agency. We do have a facility, astronaut training facility, which is located in Bangalore. It's near Marathali. There we have developed and all the 4 astronauts who are identified are being trained there for our Gaganyaan mission.
Thank you.
We will.
Courses.
Rachna ma'am, we need your help here.
We have our HRDD department
stream, or you can also have MSc in physics, chemistry, biotechnology. We have just started because our human spaceflight group is coming up. Otherwise, main is engineering stream, or we also have admin staff where with normal degree you can also get into ISRO. If you have completed your engineering or your MTech, you can get into ISRO. We have a written examination called ICRB, ISRO Center Recruitment Board. So there will be a question paper set and given to you. You are supposed to write that, pass that examination, and then you are inducted into ISRO. That is a procedure. Or if you are, there is also opportunity for you to come through GATE score. If you have given a GATE exam, through GATE score also you can come. But the chances is very less. 25% of people only come through GATE score, otherwise 75% people are through ICRB only. Mechanical, computer science, we have many stream of engineering, you can come into ISRO.
Thank you, ma'am.
Welcome.
In India, they've been preparing a plan to start its own space station. So how is the preparation going on about that, and what would be the budget expected?
So actually, India is, as you know, Bharatiya Antariksha Station. That is the name of the space station which India is planning. And recently, the models was unveiled in Delhi. Okay, recently I have seen that actually. So we are starting the project. Maybe by 2035 to 2040, we will be able to realize our Bharatiya Antariksha Station. So budgetary, it's not clear yet. So government has allotted enough money to start, and the total budget we can't estimate it right now. It will be in terms of thousands of crores. At least it will be like 50 to 60,000 crores. So a lot of technologies have to be proven. Okay, so we should not try to quantify in terms of the budget. So many technologies we have to prove, we have to test it. It has to be flown in different satellites, different Gaganyaan missions. So after that, the base station will come up. Currently, we are on the project.
And
Thank you.
Presentation, we have started the first step like docking. So we already launched 2 satellites. We had our own docking mechanism, and we have seen that it has worked docking in the space. Means our Bharatiya Antariksha Station is having 5 modules, and we cannot launch all 5 together, no? We'll be launching one by one, and finally it has to dock each other, it has to make a space station. Okay, so for the docking mechanism, our own docking mechanism we have established already, and further to matching with ISS, we are having some more missions like SpaceX 2 and SpaceX 3. We are proving along with their standards, and that whatever you are telling, we already initiated the process. It is a big process, as he told. It takes time, and maybe by 2035 we will be able to achieve this.
See, if you see, today we are trying Gaganyaan, where the crew will go and the crew module will return to the Earth. If you see, in 2008, we had actually done SRE, Space Recovery Experiment. So it was a precursor to that. So we have to prove different technologies, and we have to fly those things. So similarly, as Rajeshwari rightly told, SpadeX is one of the technology where we use docking. So budgetary we can't quantify, but lot of technologies as a spin-off will come out of in the process of doing BAS.
Like you are preparing many missions or rockets, so you will be having some of the health issues or you will be having the stress towards it, like to succeed. So how will you overcome that stress and health problems?
Our environment is very stressful, especially when missions are in the final phase, launched, and we are trying to control and do experiments. There are days like we reach the office on day 1 and we can go back home only after day 4 or 5. We'll forget all about our sleep and eating everything. So we should be very conscious on taking care of our health. We also have, our office has all our like health benefit. I mean, there is a gym available, there are yoga classes there, and there is an option to do meditation. So our office gives us a lot of facilities to take care of our health, and we should be very conscious. We also have lectures like how to take care and how to manage our work and life balance or stress levels. And one thing I would say is everybody in ISRO, they work there for passion. And it's not like a 9-to-5 job or we just come there for earning some money or something. If we are designing or testing or even facilitating the mission, we put our complete self. So when we are doing that, we don't feel stressed. I cannot say not feel stressed, but it's not like a imposed pressure on us. We take it like it's our mission and we have to do it. And that gives us immense satisfaction. So that is one level, it keeps us happy. And being happy is very much important to be healthy. So that way I can say each and every individual from our technician, technical level till our highest director to highest scientist, everyone puts in complete 100 to 200% of their heart into the mission. So that is one of the main criteria driving us, not any other pressure or anything. Anybody?
As you suggested, no, as you told, there will be a lot of pressure. Why? Because in space technologies, right now ISRO is the only organization in India which has to do. We have to do many first times. Okay? We have to do many first times. And there will be a lot of pressure. And the whole country will be looking at it. So if you see the Chandrayaan 3 launch, the whole country was looking at it. So we have a lot of pressure, undoubtedly. But the success which we get out of it, no, we get a lot of energy from that. And we go back to work for that actually. So we get a lot of satisfaction when the first time things, so we are doing for the first time. We don't have a heritage for that. Okay? We will be trying out and you get a lot of energy actually. So we get so much motivated. We have seen our seniors working. As Priyanka rightly said, they will be there in the control center for 48 hours. We have seen without sleeping. People who are aged 50, 55, 60, 70 years. You see our previous chairmen will be there for the review. We have seen during Mangalyaan mission. So morning 9 o'clock they will start the meeting, review meetings. Till 9 o'clock it will happen. So next day we have to come back again at 9. And many times we have to do some experiments and get the results and come prepared for the next day morning meeting. So we have a marathon meetings, marathon reviews. So it will be very stressful undoubtedly, but a lot of learnings will be there in the process, and when a small success also we celebrate. So there's a culture and heritage in ISRO where we learn a lot of things and we enjoy, because it's the first time. It's the first time things we only have to do. Nobody else will do. Okay, we have to set the path. Okay, we derive a lot of satisfaction, that of inspiration from the results. Small results also we derive, and that's how we can reduce the stress.
Apart from this, I want to add, we are very grateful to our family members also. They know what kind of work we are doing and they will give full support for us. Without their support, we cannot do anything. You also know.
Huge round of applause for that, you know.
Really, we have to thank our family members.
To make satellites.
Okay, satellite has got many material. You can see there is one yellow color. Inside that it is called a structure. Means there are many packages are there inside. Each one is having lot of functions to carry out. So that packages will be assembled on a one plate that is called CFRP material. It is like you are building a wall, no. Those walls are there, it is a CFRP material. After that, if you see solar panel, they have to place the solar cells to generate energy. Those cells are also put on one of the sheet that is also part of CFRB, where they will place the solar cells. Then you can see some yellow sheet. That is a thermal sheet which will protect our spacecraft from the space environment, because we have defined a life for the satellite. It may be for 5 years, 10 years, 15 years. So we have to protect our satellite, correct? So like how you will wear your sweater, like that. So that is the thermal sheet, it will protect. It is a multi-layer material, it will protect. Like that, many materials are there, and all materials are red hot components, means it is radiation, it can withstand in the space. So it is, we cannot use which is available in the commercial, where normal shops. All components are space qualified components. For that, special tests are there. Each component wise, it has to undergo through the special test. After that, we'll do some special extra, as part of satellite also we'll do some vibration, acoustic. It has to withstand all those things. So it is stiffness, everything will be verified before making a satellite.
Thank you, ma'am.
Last two questions. This student, and then we'll come to you.
My name is Sanchit. My question is ISRO planning to study gas giant in the near future? Gas giants.
And we have some more Mars missions, Chandrayaan 3 lander missions, all those things. And we have Astrosat mission, actually. Okay, it studies about our space and different galaxies and all those. Not specific to any gas chains like that.
System, okay. We are having GPS is generally what we are using, but we are depending on somebody else, correct? We should have our own system. That dependency should not be there. And navigation system will provide it works on two concepts. One is for common people. Instead of GPS, we can use our own antenna, and even common people can use that signal. It gives your location and the time to reach your home, so that our Navic also will give. And apart from that, we are having one more concept called defense, where it is a restricted service. It will only provided for our defense, airplane, all those agencies we are providing. So we are not, technically we are not depending on GPS. We are having our own Navic system, and we are in par with GPS.
Actually, there will be some zones where it is called jamming zones, orbiting all throughout the earth, and we want operations to be conducted anywhere. Imaging or any experiments, there are a lot of jamming zones which will restrict our operation time. So if we rely on GPS, we will have to plan our operations only in a specific time. So that's why we are going towards our indigenous Navic, where we have all the freedom. We can do whatever whenever we want.
Yeah, so we'll take this last question.
And
yes, ma'am.
I just want to add some more.
Yes, yeah.
See, actually, we have a slightly good story about this Navic satellites, okay, our own Navic thing. During Kargil war, our soldiers were not allowed to use GPS. We were denied of the service. So that's the time when Government of India and ISRO found the need that we should have our own Navic satellites, okay. So we were able to establish that in a record time of 10 to 12 years. Okay, we had our own constellation. Basically, Navic satellites, IRN is a series of satellites they are using for Navic. So we were able to come out with our own constellation. Okay, and we have Mr. Naveen actually, who has worked in Navic receivers. Okay.
Huge round of applause for Navin, sir. Please stand.
What was your role? Please explain.
Wonderful question.
No, whatever is in the social media, I will repeat. So our satellites and Navic signals were used for Operation Sindhu. And certainly it helped our armed forces in their
Worst environment, if you assume there is something called, I don't think you guys will know it, it's called 3 sigma. It work normally up to 3 into how much they give the rating. So we have tested to even 30 times what it cannot perform. We were sure that it will land. And simulations went on from July it was launched till August. There was a team of at least 10 people there in the control I don't want any of what we have tested is coming through. This was the level of confidence we all had, at least from our group point of view. I come from the smile came back only after landing. This was the amount of dedication and confidence we had when Chandrayaan 3 landed. Yeah, anyone wants to.
ಕೊಡಗು ಧ್ವನಿ ಡಿಜಿಟಲ್ ಮೀಡಿಯಾ, ಇದು ಕೊಡಗಿನ ನಂಬರ್ 1 ಯೂಟ್ಯೂಬ್ ಚಾನಲ್.
ನಾನು ನಿಮ್ಮ ಜಗದೀಶ್, ಕೊಡಗು ಧ್ವನಿ ಡಿಜಿಟಲ್ ಮೀಡಿಯಾದಿಂದ. ನಮ್ಮ ಚಾನಲನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ.